Hello, everyone. We're about to start lesson 3-4, investing in yourself. Our learning objectives is to understand different student loan options, to compute interest and monthly payments on a student loan, to evaluate the effects of capitalized interest, to analyze various aspects of a mortgage, compare two mortgages of different lengths, and to prepare an amortized schedule. If you think education is expensive, try ignorance. Okay, now everyone knows that college is expensive, and some folks have opinions on whether or not it's really worth the investment. The numbers, however, say that it absolutely is, since your earning potential with a college degree increases to the point that you'll make back the cost long before retirement. When it comes to credit card debt, the best advice is often don't. But that's not a viable option for college costs, since the cost of not going to college is far more in the long run than the cost of attending. That makes student loans a necessary evil for most folks. And when you're finished with college and making a living, many of you will make the most expensive and rewarding purchase of your life, a home. If there's one common theme in this unit, it's that is that understanding the nuances of the financial transactions you're likely to deal with makes you far less likely to end up in a bad situation. Now we look down here at the bottom. There are three basic types of loans that most undergraduates might consider. Federal loans made by the government, federal loans made by banks or other lenders, but guaranteed by the government, and private loans. Every student's first choice should be the federal loans due to stability. The interest rates are fixed for the life of the loan and are regulated by Congress, so you're unlikely to end up with a nasty surprise somewhere down the line. There are, however, limits on the amount that can be borrowed for one student through federal loan programs, and private loans might be the only alternative for an especially expensive education. Other than the length of the loan, the big difference between the student loans and other installment loans is that the payments are typically deferred until after graduation. This makes perfect sense, as in many cases, students aren't working enough to make the money required to keep up with payments. So that's a pretty good deal, but it comes with a catch. In some cases, interest will accumulate on your loan while you're in school, even though you're not making any payments. This can increase the principal balance considerably. The loan term can vary depending on the amount borrowed, but the standard term is 10 years with payments deferred until 6 months after graduation. Now, interest on student loans is simple interest. The interest accrues only on the principal balance, not on previously accrued interest. So while the student is still in school, the amount of interest that accrues each month remains constant. The interest is calculated using the simplified daily interest formula, which we can develop using things we know about simple interest. Number one, if the principal balance of a loan is $6,500 and the interest rate is 6.8% annually, how much simple interest will accrue in 1 year? So the simple interest formula we know is interest is equal to principal times rate times time. So the interest is equal to the principal was the $6,500. The rate is 6.8%, which we'll change to a decimal to 0.068, and then the time is 1 year. So when we multiply all these values together, it would give us $442. Now, number two, why does it make sense to use 365.25 days in a year for financial calculation? It makes sense to use 365.25 days because of the leap year every 4 years. So if you think about it, in the leap year, you have one extra day. So if you take that one day that you would get extra every 4 years and divide it by four, is 0.25. So if you add 0.25 days to each year, it will work out to that one extra day that we get for the leap year. Now, number three, it says using questions one and two, find the daily amount of interest that accrues on that $6,500 loan. Make sure you explain how you got your answer. Okay, so basically, with number three, we would take the $442 and we'd divide it by the 365.25 days. So that would give us $1.21 when we put it in our calculator. Be $1.21. So it asks us to explain this. We divide the simple interest for 1 year by the amount of days in a year. And remember, we're using 365.25. Okay, number four. It says how much interest accrues in a month. For our purposes, we could use 30.44 for the number of days in a month. That is 365.25 divided by 12. Okay, so we'll take $1.21 and we'll multiply it by the 30.44 days. And that will give us how much interest will accrue in a month. So that would give us about $36.83. Now at the bottom here, we have the simplified daily interest formula. Daily interest amount is the principal balance times the interest rate divided by 365.25. And the monthly interest amount is the daily interest amount times 30.44. Okay, now we move on to the next page here. And on page 311, it says, for that $6,500 student loan we've been working with, if you start school in August, graduate in May, that's 3 years and 9 months later, and payments begin 6 months after graduation, how many months will pass while interest is accruing? So if we look at this, we had 3 years, 6 months we were given. And then now wait a minute, oh, that was 9 months. 3 years and 9 months we were given. Okay, so, and then we wait 6 more months after graduation. So let's add these months together. So we still will have our 3 years, and 9 months and 6 months is 15 months. Now remember, our final answer we want in months. So first of all, we know 3 years. If we take 12 times 3, that's 36 months for 3 years. So we'll take our 36 months plus the 15 months that we have here. That would give us a total of 51 months for interest to accumulate. Now it says how much total interest accrues before payments begin. So we would take the answer from problem number 4 for the month, which is $36.83, and we will multiply it by how many months we have, which is 51. Now, when we do the multiplication here, it'll be $1,878.33. That's how much interest would have accrued. Now, it says when interest is covered by the government while the borrower is still in school, a student loan is called subsidized. If interest is added to the principal while the borrower is in school, the loan is called unsubsidized. For the loan in questions 1 through 6, the student would have saved $1,878.33 by acquiring a subsidized loan. When monthly payments begin on a student loan, they're based on the principal balance at that point in time. These payments can be computed using the following formula, which should look familiar. It's exactly the payment formula we studied in lesson 3.3. We just thought we'd be nice and recopy it rather than making you page back. You should probably send us a thank you note or maybe some homemade cookies. Also, since most student loans have a 10-year term, we took the liberty of adapting the formula to that situation. Again, you should probably send us cookies. Okay. Now, when they say they adapted this formula to go with the 10-year term, this is the part that they adapted, the exponent. Instead of it being a negative n times t, because n was the number of times the payments will occur or the interest would occur times the number of years. They did that here with this negative 120 to indicate 10 years. So it says for a 10-year student loan with principal P and interest rate R written as a decimal, the monthly payment M is given by, and we have this formula. Reminder, perform the calculation in one step if you can. If not, don't round too much. So here's the reminder that I would say to you. Because you can use Desmos, you have no reason to go through and try and round as you go. You could basically round after you calculate the whole problem in Desmos. Now, number 7, it says for the loan in questions 1 through 6, what is the principal amount at the time payments begin? Okay, so we borrowed $6,500. But remember, the interest that accrued on the loan, and we're assuming that you did not have a subsidized loan, is $1,878.33. So then when you add these two together, your new principal would be $8,378.33. That would be your new principal. So now we want to find the monthly payment on the loan. So we had M is equal to, now we would take our principal or the new principal, which is $8,378.33, and multiply it by the interest rate, which was 6.8%, divided by 12, all divided by 1 minus 1 plus the interest rate, which is 0.068, divided by 12 to the negative 120 power. Now, we could put this in our calculator. So we had 8378.33, and I'll put the division bar there. And then we would have times 0.068 divided by 12. And then in our denominator, we have 1 minus parenthesis 1 plus 0.068 divided by 12. Press this arrow here, close off the parenthesis. Then we would take this to the negative 120 power. And that would give us a payment of $96.42. Because remember, we only go 2 decimal places with our money. So we've seen that with a student loan, you have the option of not making any payments until after graduation. When interest on an unsubsidized student loan is not paid during college, we say that the interest is capitalized. When interest is capitalized, it adds to the principal balance, which of course results in larger payments. That's what happened in the example that we've been working with so far. When interest is not capitalized, payments have to be made during college, but only covering the amount of interest. This keeps the principal balance the same until full monthly payments start, which makes those payments smaller. For the student loan we've been working with, the payments while still in school would simply be the amount of interest that's accruing, which you already calculated. For reference, in the space below, write the amount you pay in an average 30-day month, as well as the total amount of interest you pay before regular monthly payments begin. Now, so we can have our monthly interest, which we got in problem number 4, which was the $36.83. And then we could write down the total interest, which we basically wrote in problem number 7. No, actually, yeah, we did write in 7, but it's this portion here. It's $1,878.33. Now, number 9, with interest not capitalized, the principal balance of the loan will still be 6,500 when full payments start. Find what those payments will be. How much less is that per month than if interest is capitalized? So listen, we don't have to reinvent the wheel. I am going to rewrite this. Instead of having the $8,378.33, it'll be 6,500 for the principal, and everything else will remain the same. So all I have to do in my Desmos calculator here is change that value to 6,500. And now I have my monthly payments, which is $74, or it should be approximately $74.80. Now they want to ask how much less is it than what it was uh, if it would have been capitalized. So $96.42. So the non-capitalized portion of this would actually be $21.62 less. Okay, and comparing the loans with or without interest capitalized, certainly we'd be interested in finding the difference in the total cost of the loan. So now the key question when studying whether capitalizing interest is a good idea, discuss with your group whether or not you think the amount saved by paying interest while in school would make it worthwhile to scrape together the money to make those interest payments while still a student, then write some of your thoughts. Okay, now these answers would vary, but basically here, they gave us basically the same scenario that we had here. Let me see. Okay, actually, yes. We have basically the same scenario here, but what they did here, they multiplied out to show you how much total you would pay with the interest being capitalized, which means it was added back in. And then here, where the government paid the interest, and you started off with the 6,500 you initially borrowed. They found out how much it would be after the end of paying it for 10 years, and then what they did with the payments that was not capitalized, they had to add in the amount that you paid too. So this would be the total amount that you paid, the 89.76, and the interest that you paid. So it'd be $10,854, and then you subtract these two values. And so basically you save $716.07. Now the question is it worth you saving $716.07 to come out of $1,878.33 while you're in school? And I would say it depends on the responsibilities I have. and my income. So basically, if I'm living at home and say I found a job making 15, $16 an hour, then paying that 1800 over the life of me going to school wouldn't be so bad. But say I'm staying in housing and have to pay for it and only have a financial aid job or, some type of work study job, then I might not be able to pay it. May not be worth me scrimping and saving like that just to save $716 over a 10-year period. So I'm basically saving a little less than $72 a year. So that's why I say it really depends. But if I have it, why not save it? Okay, now for the home buying, you could read the scenario they have here, but I want to go down here to the first highlighted word. A mortgage is a long-term loan where the lender has the right to seize the property purchased if the payments are not made. Homes are the most common items bought using mortgages. The most common mortgage term is 30 years, but they are widely available in terms from 10 to as many as 50 years. There are several types of mortgages. With a fixed rate mortgage, the rate of interest remains the same for the entire term of the loan. The payments, usually monthly, stay the same. With an adjusted rate mortgage, the rate of interest may fluctuate, increase and decrease during the period of the loan. If you opt for an adjustable rate mortgage, it will start out with a lower interest rate than a fixed rate loan of the same length. So number 11, it says discuss the pros and cons of fixed and adjustable rate mortgages. Okay, basically, I'm just going to do one pro for each. For the fixed, I just say pro. For the fixed, you know how much you pay each month. That's a pro for the fixed. For the adjustable, I just put ARM. That's what they call it, an ARM. You could get a lower interest rate. That's the pro. Now the con for the fixed, rates may go down, but your rate will stay the same. And then the ARM for the adjustable rate mortgage, rates may go up and you will pay more interest. Now, number 12, it says discuss the pros and cons of buying a home compared to renting a place to live. I'm just going to do one pro and con for both. So the home and renting, the pro. Home, you own it and can accumulate equity. Renting, you are not responsible for repairs on items that may break. The con of a home, you have to pay for everything. The con for renting, you do not own it and are at the mercy of your landlord. Okay. Now we move on to the next page. It says one of the most useful but frightening things about home buying is calculating how much money you will actually pay over the life of a loan. Let's see how that might work for one family. The Petty's family plans to buy a home for $224,900 and has been offered a 30-year mortgage with a rate of 5.5% if they make a 20% down payment. Calculate the down payment and the amount they'll have to borrow. Okay, so basically, said 20% down payment. So you would take 20% of the full cost of the home. So the down payment would be $44,980. That's after you put in your calculator. Now, you want to find out how much you have to borrow. So you would take the price of the home minus your down payment. And what you would need to pay is $179,920, or should I say, you would need to borrow, not pay, but borrow. Okay, now 14. The monthly payment on the loan will be $1,021.57. How much will the Petties actually pay for their $224,900 home? So we would take the 1,021.57 and multiply it by, they have a 30-year mortgage, multiply that by 360. So let's do that. We have 1,021.57 times 360, and that gave us $367,765.20. But remember, we also have to add in the down payment we put. So that would be an additional $44,980. Now, when we add all this together, it'll be $412,745.20. That would be the total cost that the person would pay for the $224,900 home. Almost double the price. Okay, now when you apply for a home loan, the lender will tell you what your monthly payment will be. And if you're an incredibly trust and sort, that might be good enough for you. For most of us, though, a double check of the quoted payment would be a big comfort. In addition, knowing how the payment is calculated makes it quite a bit easier to understand the factors that determine how much you will pay. Better still, it would allow you to compare mortgages with different rates, down payments, and length. So let's have a look at computing monthly payments. Okay, now it says in the space below, recopy the formula that we use for computing monthly payments on a student loan with a term of 10 years. Then describe the significance of each part of the formula requested below. So we had M is equal to P times R over 12 divided by 1 minus 1 plus R over 12 to the negative 120 power. Because remember, we're doing the 10-year period. Okay, so we know P is the principal. R is the rate, or we should say interest rate for the year. And then 12 is the number of payments per year. Okay, it says, where do you think the 120 comes from in the formula? Hint, think of 120 as the product of two numbers. The 120 comes from multiplying the years, and I'll put in parentheses 10, by the number of yearly payments, which would be 12. So that's how we get our 120. Now it says use your answer to questions 1 and 2. Adapt the student loan monthly payment formula into a general formula for finding the periodic payment on a loan with principal value. Okay, listen, that is given to us here at the bottom. So we could just write this out. Now, if you look here, and I'll compare it to the formula up here. We know R is our interest rate, but look here at N. N is where the 12 is. So since it's monthly payments, we know it's 12 months in a year. That's how they got the 12. And then for the negative NT, remember N is the number of payments, which is 12. And then T is the amount of years, which is 10. So that's how we get the negative 120. Now let's use our snazzy new formula to study some variations on the mortgage we've been working with. Okay, so now we're going to go down here to number 4. It says, now let's examine the term of the loan. If the Pettys chose a 15-year mortgage with 20% down payment and 5.5%, what would the monthly payment be? All right, so with that being said, we already know our principal wouldn't change because it's still a 20% down payment. So our principal would still be $179,920. Now our rate would still be, well, our rate is 5.5%. So we'll make that a decimal, still divided by 12, be 1 minus 1 plus, still be 0.055 over 12. Now, when we get to the exponent, we know it's negative. N is 12. And then we know that since it's a 15-year mortgage times 15. So this right here, I'm writing this out so you can see it. Negative 12 times 15 is actually a negative 180. So I'm going to write the negative 180 here. Now, if you don't know that, you can always type it in the calculator. Now, when we put this in our calculator, it would give us $1,470.10. That would be our monthly payment if we did 15 years. How would their total cost compare to the other two options we studied? All right. So with that being said, okay, when they say the other two options, the first option was a 30-year, 20% down. This right here with the solve example, this gave you basically 10% down with 30 years. So this is the second option, and this is the third option. So the first was 20% down 30 years. Second option, 10% down 30 years. And then finally, this option here, which would be 20% down 15 years. So we want to compare them. Okay, so we go here. We have the new amount, which was the last amount. We will have, it'll be 180 payments times the $1,470.10 plus the down payment of $44,980. And that would give us a grand total of $309,598. Okay, that would be the new one. I just put that as number 1. Number 2, would be the 20% down, the initial one we had. So it'll be $412,745.20 minus the $309,598. Because we had solved this totally out, we had found out how much it would be totally for the mortgage, for the 30-year with 20% down. We solved that on problem number 14 on page 315. So we're comparing it to this new amount. So we subtract it and we pay $103,147.20 more. Last but not least is the 10% down. So they gave us the answer here, which was the $450,044. Then we subtract the $309,598, and that will leave us with $140,446 more. And then it says, what mortgage do you think is the best choice? It just depends on how much money you're willing to spend per month. Now, if you have enough to pay the 14, 70, 10, then yeah, I would do that one because you save over $100,000 in the other scenarios. But if you don't, then you have to pick one or the other one. So it just really depends. Okay, now we go here to the back. It says computing and amortization schedule. After securing a mortgage, the lending institution will prepare an amortization schedule. This schedule shows what part of the monthly payment is paid on the principal and what part of the monthly payment is paid in interest. Here's the procedure for computing an amortization schedule. Step 1, find the interest for the first month. Use I equals PRT, where T is equal to 1/12. Enter the value in the column labeled interest. Step 2, subtract the interest from the monthly payment to get the amount paid on the principal. Enter this amount in the column labeled payment on principal. Step 3, subtract the amount of the payment on principal found in step 2 from the principal to get the balance of the loan. Enter this in the column labeled balance of loan. Then finally, step 4, repeat the steps using the amount of the balance found in step 3 for the new principal. All right, so we're going to apply all of this for problems 6 through 10. So now it says in the next group of questions, we'll use these steps to compute the first 3 months of an amortization table for the Petty's loan. Principal is $179,920. The rate is 5.5%. Monthly payment is $1,021.57. A template for the table is on the next page. Fill in the information as you find it. Number 6, calculate the interest for the first month on the loan and put it into the interest column on the table. Okay, so we have interest is equal to principal times rate times time. The principal was $179,920. The rate is 0.055. And the time we know would be 1/12 to get the month. So the interest would be $824.63 for that month. Now we go on to problem number 7. It says subtract the interest from the monthly payment to get the amount paid on the principal. Then put that amount in the appropriate column in the table. So our payments is $1,021.57. So we'll subtract the interest, which is $824.63, and that would give us $196.94 that will go to the principal. Now, they asked us to take these answers, and we're supposed to put them in this box here. So the $824.63 will go under the interest, and then the payment on the principal will be 196.94, and then the balance on the loan, we will subtract the 196.94 from the 179,920, and that will give us 179,723.06. Now, just so you can see it, we have 179,920 minus the amount that goes to the principal, the 196.94, and that's how I got this value here. Now we need to repeat this. Well, number 8, it says calculate the new balance of the loan by subtracting the payment on principal from the original principal, then put that in the last column. We already did that. That's what I just did with you all. Guess I jumped the gun here. And that gave us 179,723.06. Now, number 9, it says repeat the previous steps for the next 2 months. Do your calculations in this space, then put the results in the table. Now, what we would have to do is do interest is equal to principal times rate times time. The principal is this new amount here. So the principal would be this 179,723.06 multiplied by the rate. The rate was, what was that, 0.055, and then it'll be 112. Still be the same formula. The only thing that changed was the principal amount. So now this would be 823.73. So now this would be 823.73. And then we have to subtract this from the new principal. So it'll be, oh, actually, we would take the $1,021.57, which are our monthly payment, and subtract the 823.73. Okay, and now after we subtract, we would get $197.84. So we will put that here. And then, of course, we will subtract that from this principal here. And that would give us $179,525.22. Now, and I'll just show it up here just so that you will have it in your records here. So we'll take this value minus the 197.84. That will give us 179,525.22. Now we have to redo the interest formula, principal, rate, and time. The new principal is 179,525.22 times the rate, which is 0.055, times the time, which is 112. Okay, when we multiply this out, it'll be 822.82. So it'd be 822.82. And then what we would need to do is take the $1,021.57 minus 822.22, which would be 198.75. So this would be 198.75 that will go towards subtracting from the principal. So we will have 179,525.22 minus 198.75, which would give us 179,326.47. So we have 179,326.47. Now it says, what does this table say about what the bulk of your payment goes to when you begin making payments on a mortgage? What about near the end of the term of the loan? So at the beginning, most of the money goes to interest. And near the end, most of the money will go to the principal. And this is it for section 3-4. Have a wonderful day.